It's coming. Not someday, not theoretically, but on a date we can circle with ink. December 19. Not a metaphor, not a projection, but a date real, scheduled, and already logged into the astronomical databases of every major observatory on Earth. Something is coming. Not from within our solar system, not from the quiet rhythm of repeating orbits. This object does not belong to us. It was not born here. It will not stay. It is a visitor. And it has a date. 3I. Atlas and Interstellar Comet. It was discovered in 2024, confirmed not long after, and ever since, it has been watched, tracked, modelled. Its path through the solar system is not chaotic, but calculated. It will pass Earth in December 2025, specifically on the 19th day of that month, at a distance of roughly 1.8 astronomical units. That's close. Not close enough to worry, but close enough to matter, because this is not just another comet. This one is interstellar, only the third confirmed visitor of its kind, and it will never return. That makes December 19th more than a date. It makes it a window. You might be wondering, what happens when something from another star system enters our own? The answer isn't dramatic in the Hollywood sense. There are no alien transmissions, no gravitational chaos, no fiery sky, but there is data, there is structure, there is chemistry, there is light, and there we are, watching. Because no matter how calm the night sky may appear, we are not alone. Not in the sense of aliens, but in the sense of motion. There are travelers, messengers, chunks of ice and rock, formed under alien stars, drifting for millions of years through the black, until, just once, they brush past our corner of the galaxy. This is one of them. 3I Atlas was ejected from its birth system by forces we can only model. It has crossed the space between stars, not through any intent, but through gravity, time, and chance. And now, it's here. This isn't a drill. The date is real. The object is real. The science is real. And most of us, they have no idea. What does it mean to observe something that will never return? Astronomy often deals in distances so vast they erase human urgency. Stars explode, planets form, galaxies collide, and all of it takes eons. But every once in a while, a moment appears on our own human timeline. One that will occur, one that we will witness, and one that, if missed, is gone forever. December 19th is that kind of moment. Because 3I Atlas is not bound to our Sunday. Its hyperbolic orbit ensures that after its flyby, it will leave our solar system and continue outward permanently. Its velocity is high, too high to loop back. It is not part of our solar family. It is not gravitationally captured. It will pass, curve slightly, and then escape. When it leaves, it will join the galaxy of wanderers, and we will have lost our only chance to study it up close. We only get one shot at this, not because the instruments will fail, not because the orbit is unpredictable, but because the geometry of this event will never repeat. This interstellar object will come close to us only once, in our entire lifetime, in all of recorded history, and it's happening soon. If something from beyond the stars reaches us, and we don't notice, does it still change who we are? There is something quietly extraordinary about a confirmed interstellar comet. Most of the objects we observe, planets, moons, asteroids, comets, are locked in orbits shaped by our Sunday. They repeat, they return. Even long-period comets, though they may take hundreds or thousands of years, are still gravitationally bound to our system. But not this. 3I Atlas is a drifter, a rogue, a body cast out from some far-off star system perhaps billions of years ago. Since then, it has wandered cold and alone through interstellar space until gravitational interactions brought it within range of our Sunday, and now, briefly, it glides through our view. In its coma, the cloud of gas and dust surrounding its core are the chemical fingerprints of another world, another star, another time. We don't know where it came from, and we will never know exactly where it's going. But we do know when it passes by us, and that date is fixed, December 19. We will not see fire in the sky. We will not see it with our naked eyes. It will appear in telescopes as a faint smear of light, slowly shifting across the stars. But the faintness of the light does not diminish its meaning, because behind that smear is a story a structure, a history we are only just beginning to understand. And in the presence of something so old, so far-traveled, and so brief, we might discover a new kind of awareness. Not fear, not spectacle, but something quieter. Wonder. The calendar doesn't lie. The orbit is locked in, and as December 19th draws near, one question remains. Will we just let it pass? Or will we look up quietly, collectively, and witness the moment a visitor from another star system comes closer to us than any confirmed interstellar comet has in all of recorded history? It looks like a speck, a smudge, maybe, a silent blur on a black canvas filled with more familiar names: Jupiter, Saturn, Ceres, Halley. And yet, 3I, Atlas, is something else entirely. This isn't just another comet. It isn't bound by the rules that shape the rest of our solar system. It doesn't orbit our sun in long ellipses like Halley's comet. It doesn't fall into predictable paths like asteroids. It does something different. It enters. And it leaves. That one fact that its trajectory is a one-way path through our system is what defines it. That's what makes it interstellar. But let's step back. How do we know this object is from another star system? What qualifies it? And what exactly is it doing here? To begin, let's talk about its orbit. Most objects in our solar system trace elliptical paths. These ellipses may be tight or stretched, but they are closed. They loop. They repeat. That's what orbits do. They keep coming back. 3I. Atlas does not loop. Its path is hyperbolic, a curve that enters and exits the solar system without circling the sunday. This is not a guess. It's not just a mathematical curiosity. We've observed it. Astronomers have taken hundreds of measurements over time, refining the object's trajectory, stripping away observational noise, and confirming this object is not gravitationally bound to the sunday. It's moving too fast. Its velocity at perihelion, the point of closest approach to the sun, was calculated to be over 43 kilometers per second. That speed is above the escape velocity of the solar system at that distance. In other words, it's not slowing down enough to be captured. It came in fast, and it's leaving fast. There are a few ways an object can achieve that kind of speed. Some bodies born inside the solar system can be kicked into hyperbolic paths by gravitational interactions with planets, especially Jupiter. But when this happens, we usually have a record of the gravitational assist. The object's previous path is well understood, and we can trace how the orbit changed. 3I, Atlas doesn't have that history. Its inbound trajectory shows no sign of solar system influence. It entered from the outer darkness, already moving fast, already on a hyperbolic path. That's the first clue. The second is the object's orbital eccentricity. This is a measure of how stretched an orbit is. An eccentricity of 0 means a perfect circle. Anything between 0 and 1 is an ellipse. An eccentricity of 1 is a parabolic escape path, the boundary between being bound and unbound. Anything above 1 is hyperbolic, unbound. 3I. Atlas has an eccentricity above 1.003. That may sound small, but in celestial mechanics, that's enormous. And more importantly, the margin is outside the error bars. That is, we're sure it is not from here. The object's official designation 3I, Atlas, tells the story in shorthand. The 3I means it is the third interstellar object ever confirmed. The first was Oumuamua, discovered in 2017, which shocked the world by being fast, tumbling, and oddly shaped. The second was 2I, Borisov, found in 2019, which behaved more like a traditional comet, but with chemistry that hinted at an alien birthplace. And now comes the third, 3I, Atlas. Atlas refers to the survey that discovered it, the Asteroid Terrestrial Impact Last Alert System, a wide-field telescope program scanning the skies for anything that moves. It was Atlas that picked up the first faint signs of this object in early 2024. Since then, it has been confirmed by multiple observatories, modelled by JPL, and catalogued in the Minor Planet Center's official database as an interstellar visitor. But it's not just about labels. What we're seeing is not merely another frozen rock. We're seeing a messenger from beyond. Why does that matter? Because 3I, Atlas, offers us a snapshot of another star system's debris. Every interstellar object we detect is like a sample return mission, except we didn't send a probe. The galaxy sent it to us. Its ice, dust, and gases are not leftovers from our sun's formation. They are the residue of a completely different environment, different pressures, temperatures, radiation levels, chemical ratios. To analyze 3I, Atlas, is to reach across light years and touch the outer shell of another world. We don't get many chances like this, and that's what gives December 19 such weight. This isn't just a comet sighting. This is the third time in all of human history we've had a confirmed interstellar object within range of serious observation. That's not hyperbole. Before 2017, we had never seen one. Ever. For all our centuries of skywatching, it was only in the past decade that we even had the telescopes, survey cadence, and motion detection algorithms fast enough to catch something moving that was oddly across the sky. It's like watching a deer walk through a flock of birds. The movement pattern is wrong. The direction doesn't fit. The trajectory says, I don't belong here. That's 3I, Atlas. And now that we know what it is, we can start asking the more interesting questions. What is it made of? What happened to it before it reached us? Is it active? And could its behavior teach us something new about how solar systems form and fall apart? The confirmation of its interstellar nature is just the beginning. The real work, the real discovery comes next, because while its orbit and velocity confirm it came from outside, its behavior will reveal whether it's typical or extraordinary. Some objects simply pass through. They warm slightly, reflect a bit of sunlight, and leave no other mark. Others become something else. They vent, they fragment, they glow in strange wavelengths. They produce jets that defy prediction. They spin in ways we cannot explain. They release molecules we don't expect. We don't know yet which kind of visitor 3I, Atlas, will be. That's the beauty of it. It's not just a curiosity, it's a live experiment. And we're already in the middle of it. This object, this smudge of alien chemistry and momentum, has already crossed the solar system's outer boundary. It has already approached the Sunday, and it's already outbound. But for a brief window this winter, we get to look closely. We get to test what it's made of. We get to a point where everything we've built, radio dishes, infrared sensors, space telescopes at a single point, and asks, what exactly came to visit? It's not every day the galaxy sends us a question, but this one came with a date. And it's not just up to the professionals. The more we understand what 3I, Atlas, is, the more we understand what we are. Because we, too, are made of debris from long ago stars. And maybe, just maybe, the story of 3I, Atlas, is also, in some small way, a story about us. Long before it had a name, before it crossed the orbit of Neptune, before any telescope on Earth knew to look for it, this object had already been travelling for millions of years. 3I. Atlas did not rise from our solar system. It was not born of our sun, not shaped by our planetary disk, not held by the gravity that binds our local family of worlds. It came from somewhere else. Interstellar space is not empty. We say it is a void, but that's only because our senses fail to register the faint particles, the cold photons, and the occasional fragment of matter crossing vast distances. Now and then, one of those fragments enters our field of view, and in that brief moment, we get to witness a memory of another star system. 3I, Atlas, is one such memory. Its path tells us what our eyes cannot. It moves too fast. Its orbit is hyperbolic, not elliptical, not bound, not curved back toward the sun, but instead flung open like a door that never closes. Its speed exceeds the solar system's escape velocity. That alone is the signature of a foreign origin. No known natural process within our solar system can account for an object moving this way, unless it came in from the outside. It did, and its journey didn't begin near. It began far. We don't know precisely which star system ejected it. The galaxy is too large, and the exact trajectory is blurred by the gravitational interactions it experienced along the way. It may have brushed past stars, passed near brown dwarfs, skimmed the edges of molecular clouds. Each encounter altered its velocity, ever so slightly, until finally it arrived here. Not because of intent, not because it aimed, but because that's how gravity works. Long ago, something, perhaps a gas giant forming in a young planetary system, threw this object outward, ejected it, not violently, but definitively, enough to unbind it forever from its home. What happens to a rock once it is no longer bound to a star? It drifts, for ages, cold, silent, untouched by solar radiation, invisible to nearly everything. It becomes a ghost, until one day, by chance, it falls into alignment with a new system. With us, there's a kind of awe that comes not from what something is, but from how long it has travelled to arrive. 3I. Atlas is not rare because it is strange. It is rare because its path intersects ours. It is rare because it entered the inner solar system, became visible, and lingered just long enough for us to see it, before it leaves forever. That's not poetic exaggeration. Its trajectory is precise. Its path was confirmed by multiple observatories. Once it curves past the sun, it will be slingshot outward on a permanent escape from our star's influence. It will never loop back. It will not return in hundreds of years like a long-period comet. It is not like Halley. It is not like Hale-Bopp. It is not like anything we've catalogued before except for two others, Oumuamua and 2I, Borisov. And even among those, 3I, Atlas, is unique. Borisov behaved like a comet. Oumuamua didn't. 3I, Atlas, lives in the space between. It glows, it jets, but it moves like something not from here. That's the paradox. It has activity, but it does not obey the orbital rules of native comets. And in that tension, we find insight. To trace the origin of 3I, Atlas, we don't look to our Sunday, we look to the galactic background. Its velocity, approximately 26 kilometers per second relative to the Sun, is consistent with the average drift speed of stars and interstellar matter in our local galactic neighborhood. That's more than a number. It's a fingerprint. It tells us that 3I, Atlas, has been part of the background galactic motion for a long time, not just flung from a nearby object last century, but traveling for eons. Its path cuts through the ecliptic at an angle, not aligned with the plane of planetary orbits, not in the same direction as the solar system's angular momentum. Another clue: imagine looking at a perfectly synchronized dance, and then, from the edge, a stranger wanders in, moving to a different rhythm, at a different pace, with a different intent. You notice, the solar system noticed, and our instruments noticed. That's how 3I, Atlas, was discovered. Not because it was bright, but because it was wrong. Wrong speed, wrong trajectory, wrong direction, or, more accurately, wrong only if we assume it belongs to us. It doesn't. Its wrongness is the proof of its origin, and that's what makes it so special. We are trained to look outward for the extraordinary, but often the most astonishing truths arrive quietly, disguised as background motion, until someone looks close enough. On paper, 3I, Atlas, is just another comet, but in motion, it's a revelation. This is how we learn about the galaxy, not just from telescopes aimed at distant stars, but from the messengers that come to us. For years, 3I, Atlas, moved unnoticed. Now we know where it is, and more importantly, we know where it came from. Not a place, but a pattern. It came from the spaces between systems, from the periphery of starborn worlds. It is not a relic of our story, but of someone else's. And for a few more months, we get to observe it. The awe doesn't come from fear. It comes from scale. How far does it travel? How quietly it entered? How briefly we get to witness. The story of 3I, Atlas, is not dramatic in the traditional sense. There's no collision, no explosion, no brilliant sky display. But there is motion, there is light, and there is history embedded in every speck of its dust. From galactic drift to solar system encounter, this object has traced a line across space we may never see repeated in our lifetime. We are the brief intersection. We are the witnesses. And if we listen carefully, 3I, Atlas, has something to teach, not in words, not in symbols, but in its trajectory. We didn't see it coming, not right away. On February 27th, 2024, a small, faint object entered the awareness of astronomers through a subtle nudge in the data picked up by the Atlas survey in South Africa. Just a streak, a dim, fast-moving blur sliding against the stars. But the coordinates didn't make sense. Its motion wasn't typical. Its brightness curve didn't follow the usual arc. And most of all, its projected path wasn't closing back into a loop. Instead, the numbers hinted at something else. A visitor not from here. 3I. Atlas was born into public awareness quietly, as most interstellar objects are. No fireworks, no viral headlines, just a soft murmur in the sky that only a few were listening to. But the murmurs grew. Within days, follow-up observations confirmed the suspicion. The orbit was hyperbolic. The object wasn't gravitationally bound to the Sunday. This was real. Our third interstellar. First was Oumuamua in 2017. Then 2I, Borisov in 2019. Now this. Except 3I. Atlas wasn't going away yet. It was inbound, and its trajectory intersected Earth's orbital zone with eerie precision. Not collision, just proximity, but enough to raise eyebrows. By April, ground-based observatories had refined their trajectory. JPL published the data. Simulations traced its path backward and forward, confirming its interstellar nature with over 99.999% certainty. It came from the direction of Sculptor, roughly, but its exact origin point, like all interstellar arrivals, remained blurred by gravitational history. Too much drift, too many unknowns. Still, we watched. Telescopes around the world pointed toward it. Pan stars, Subaru, Gemini South. Each offered glimpses. Each returned frames where 3I, Atlas, was just a dot among dots, but the motion told the story. The object was accelerating not from engines, but from the gravity of the Sunday. And then, something unexpected. Jets, small, consistent plumes of material, were detected by their faint impact on the object's trajectory. It was outgassing, sublimating from solar heat, but the activity didn't match the usual ice signatures. No bright coma, no expanding tail. Still, it moved. Still, it glowed. And then, it disappeared. In early June, 3I, Atlas, entered solar conjunction. From Earth's perspective, it passed behind the Sunday. Our telescopes couldn't track it anymore. Not safely, not without risking damage to sensitive optics. And so, for months, the sky went silent. No new images, no updated observations, only predictions. Astronomers modeled its path through the hidden zone with increasing uncertainty. The gravitational math was solid, but small deviations in jetting behavior, outgassing, or fragmentation could shift its location significantly. Would it stay intact? Would it brighten? Would it even survive the turn? Nobody knew. This wasn't a comet we had tracked for decades. This was a stranger, and it had just ducked behind the brightest curtain in our sky. The silence became a test of patience. Between June and October, ground-based observations were impossible. Solar conjunction had blocked the only window we had. And yet, the object was still coming. December 19th, the predicted date of closest approach to Earth, loomed in the background of every new model. But how could we know it was still on track? Here's where things got strange. Despite vanishing from direct observation, some telescopes, like SOHO and Stereo, positioned in solar orbit, had limited ability to spot objects near the Sunday. Analysts scoured coronagraph images for hints of motion. For a while, nothing clear emerged. Then, a glint. In late October, a blurry dot appeared in a SOHO LASCO image, too faint to confirm, but enough to raise a possibility. Had it survived? As November arrived, a handful of ground telescopes began to point near the sun's edge again, and slowly, quietly, the dot reappeared. 3I, Atlas, was still there. But something had changed. Its brightness didn't match pre-conjunction projections. Neither did its coma size. The post-conjunction light curve was strange. Not dim, not bright, just inconsistent, as if something about it had shifted while it was hidden. That mystery only deepened the intrigue. For several weeks, the data gap left by the conjunction became fertile ground for speculation. Some suggested it had fragmented. Some argued the jets had changed direction. Others wondered if we'd confused it with another object entirely. But the core truth held. Something had crossed behind the sun and emerged again. And now it was accelerating toward its closest point to Earth. This entire story, discovery, disappearance, re-emergence, unfolded almost invisibly to the general public. There were no news alerts, no push notifications. Only a handful of science forums, orbital modelers, and astrophysics communities kept track. Because unless it's big, bright, or dangerous, The world tends not to notice. But we noticed. Because stories like this of a visitor arriving, slipping behind the curtain of our star, and then emerging transformed, don't happen often. And they don't come with a reset button. The silence of solar conjunction wasn't just an observational gap. It was a narrative breath, a pause in the signal. And in that pause, we imagined everything. That's the thing about hidden motion. You can't help but fill the silence with stories. We didn't expect it to make it. Not fully. Not without scars. 3I Atlas was never large. Not by interstellar standards. A few hundred meters, at most less than a city block across. A speck compared to the giants of our solar system, and yet it hurled itself into the gravitational well of the Sunday. Its path bent sharply. By early October, its solar approach steepened, dragging the object toward its closest encounter, perihelion, 1.08 AU. Roughly the same distance as Earth from the Sunday, not especially close, not the searing dive of a sun grazer, but enough to matter. Enough for radiation pressure, thermal stress, and outgassing to tear lesser things apart. We'd seen it happen before. See 2012 S1 Ison, once hailed as the comet of the century, disintegrated during its perihelion in 2013. Fragments, dust, and nothing more. So we watched 3I Atlas approach the sun with cautious eyes. And then once again it disappeared. Not metaphorically, physically. The sun's glare rendered it invisible to ground-based instruments. Our atmosphere and its scattering of light made observations impossible. Only space-based eyes could try. We turned to SOHO. The Solar and Heliospheric Observatory has been orbiting the L1 Lagrange point for decades, its coronagraphs peering constantly into the solar region. Designed to block the blinding solar disk, it offers a narrow window into what lurks near the Sunday. On November 3rd, a faint object entered SOHO's LASCO C3 field of view. Just pixels at first, a smear in motion. It wasn't bright, it didn't flare, but it was there. Then came a subtle tail. Not long, not dramatic, just enough to suggest outgassing was still underway. The coma, a cloud of dust and gas around the nucleus, was small, faint, but distinct. It was alive. Not only had it survived perihelion, it was active. This was the first visual confirmation post-solar conjunction. 3I Atlas hadn't broken apart. It hadn't disintegrated like Ison. It had threaded the eye of the solar needle and emerged whole. We felt it. That strange relief, because something about watching a cosmic visitor endure the heat of our star unchanged, unapologetic, touches a chord in the human mind. And we needed that reassurance. As more images came in, the object traced a gentle arc across SOHO's field. The tail pointed away from the sun, consistent with radiation pressure, but its structure wasn't typical. Instead of a long plume, it resembled a stubby wedge. Some analysts noted a possible anti-tail feature, dust pointing sunward rather than away. It wasn't conclusive. SOHO's resolution is limited, but the possibility lingered. Because anti-tails don't lie. They tell you about geometry, about dust planes, orbital alignments, and the orientation of the Earth object-Sun triangle. And that triangle was tightening. Every day after perihelion, 3I Atlas curved outward, gaining velocity as it slingshotted around the Sunday. Its trajectory began to pull away from solar proximity and toward Earth's side of the solar system, and its brightness grew, not explosively, but steadily. Ground-based telescopes began to pick it up again, first with difficulty, then more clearly. By mid-November, it was visible in 30-second exposures through moderate aperture scopes. Photometric analysis confirmed something significant. The coma was still active and likely asymmetric. Jets, still firing. A vent? Possibly. A cluster of them? Maybe. The important part wasn't how it was that it was happening. This was not a dormant rock coasting on an ancient orbit. This was a breathing, reactive body responding to its environment in real time. And the timing was perfect, because its Earth approach window was now opening. From November 25th through mid-December, viewing conditions improved rapidly. Twilight visibility returned. Astronomers began refining rotational models, estimating albedo changes, and comparing pre- and post-perihelion light curves. Here's what stood out. The brightness curve was steeper than predicted. Pre-perihelion, Its apparent magnitude followed a slow rise, consistent with a modestly active body. But after perihelion, the slope changed. Not dramatically, but measurably. That triggered two questions. First, did perihelion heat activate new vents? Second, did the object fracture internally without visible fragmentation? Some models suggested that under thermal stress, subsurface pockets of volatile material might have opened up, increasing active surface area without catastrophic breakup. This matched the observed behavior: increased outgassing, slight changes in spin rate, and coma asymmetry. It was surviving but adapting, and that's rare. Most interstellar visitors pass through passively. Borisov behaved like a textbook comet. Oumuamua, famously, didn't outgas at all, or at least not in any way we could detect visually. But 3I, Atlas, was showing a third path. Active, evolving, and perhaps stable. This was crucial for another reason. As it re-emerged and brightened, we were now able to refine the trajectory further, and the simulations tightened. December 19th, closest approach. Distance to 0.27 AU, about 40 million kilometers. That's 10 times closer than Mars ever gets. But more importantly, it would cross Earth's orbital plane almost perfectly. This geometry made it ideal for tail observations, not just of the primary tail, but of any dust trail, anti-tail, or debris structure aligned with its motion. Observers began preparing imaging stacks, filters, exposure plans. The goal: to see the ghostly lines of interaction between the object and sunlight. We weren't just watching for beauty. We were watching for clues, because the tail's structure could reveal everything: spin rate, vent location, material composition, even interior cohesion. And now, we had something rare: a surviving, post-perihelion interstellar object on a sunlit, Earth-facing path, jetting actively and carrying its own mysteries. It's difficult to explain the emotional resonance of that. We're not just tracking data, we're watching a narrative. Something arrived. It crossed the void. It flirted with the edge of our star, and it came out, changed. But whole. That story resonates with us, with myth, with survival, with meaning. Because if it can survive that, maybe so can we. We don't often get second chances in astronomy. Celestial events happen once, and then never again in the same way. That's the nature of orbital mechanics, of light, of time. And so, when we say that something will pass close to Earth on December 19, we don't mean dangerously close. We mean irreversibly close. 3I, Atlas, is on a hyperbolic trajectory. It's not looping back. It won't orbit again. That line through space, the one that brings it near Earth in mid-December, is a one-way road from another star, curving through our solar system and flinging back into the void. This isn't like a Halley's Comet returning every 76 years. It's not a known near-Earth object we can track for future flybys. This is it. December 19 is the closest point 3I, Atlas, will ever come to Earth. And that changes everything. Let's talk specifics. According to JPL Horizons, the object will reach its minimum geocentric distance of approximately 0.35 AU, about 52 million kilometers on the 19th of December 2025. That's close, cosmically speaking, closer than Mars, closer than most interstellar visitors ever get, and will be in a unique observational position. During this window, ground-based telescopes across both hemispheres, Pan-STARRS, Subaru, VLT, Gemini, will have access to the object for a short but critical period. So will radar arrays. So will amateurs with modest scopes. But that window won't last, because 3I, Atlas, isn't just approaching. It's moving fast tens of kilometers per second. The same velocity that marked it as interstellar is the very thing that will soon make it unobservable again. We are on a countdown. That's why December 19 matters not just as a number, not just as a line on the calendar, but as a threshold. Before that date, we are speculating. After that date, we are post-event. The object will grow in brightness for a few days leading up to closest approach, possibly reaching visual magnitude thresholds detectable by mid-tier observatories. But then, it will dim rapidly as it recedes. The curve is sharp. The timeline is unforgiving. Which brings us to the second layer of importance: symbolism. 3. Atlas has become more than an object. It's become a mirror, a test of how humanity responds to mystery, a test of how we listen to weak signals, a test of how quickly we dismiss what we cannot categorize. And the December 19 close pass is the moment of truth. Not because we expect it to crash, not because we think it will flare up into a celestial spectacle, but because this is the only moment we get. The only moment to record high-resolution spectra, the only moment to test radar reflection models, the only moment to potentially triangulate the interior structure based on the light curve and outgassing behavior. Every model we run today is anchored to this date. Every debate about artificiality or natural origin must meet this moment. It is the event horizon of knowledge. After December 19, we will either have caught it or missed it. And unlike comets or near-Earth asteroids, there's no next window. It's easy to think of the sky as static. Stars are fixed, orbits are stable, light arrives predictably. But that's a lie told by short timelines. In truth, the sky is in motion, everything is moving, leaving, evolving. And when something not from here enters our frame, we get one opportunity to engage. That's what December 19 is. A timestamp, a singular, unrepeatable breath in the story of our solar system. So we mark it now not out of fear, but out of reverence. Because not everything that passes near us is dangerous. Some things are simply brief. It's easy to speak of orbits and trajectories in abstract terms. Numbers glide across the screen. Diagrams loop predictably. But at some point, we want to look up and ask, what will we actually see in the sky? That's what this part is about. Because 3I Atlas isn't just a mathematical puzzle, it's a visual event, and for a brief moment, it becomes ours to witness. Let's begin with the basics. Magnitude. Current models project that 3I Atlas could reach an apparent visual magnitude of around 10 to 11 near closest approach on December 19. That's just outside naked eye visibility, but easily within reach of backyard telescopes and high-end binoculars under dark skies. Its brightness is limited by a few key factors. 1. Distance. It won't get closer than 0.35 AU, so we won't see a blazing head overhead like Hale-Bopp. 2. Activity. Although it survived perihelion, its outgassing is relatively subdued. The coma is small, and the jet brightness is subtle compared to more volatile comets. 3. Angle of illumination. The geometry between the Sun, the object, and Earth limits how much light we receive directly. But brightness is only part of the story. The real spectacle may come from shape. Why? Because of something called an anti-tail. Most people are familiar with comet tails pointing away from the sunday. That's the ion tail, formed by solar wind blowing charged particles directly outward. But occasionally, when geometry aligns just right, a dust anti-tail appears to point toward the Sun, an illusion caused by Earth's angle slicing through the comet's orbital plane. We've already seen hints of this behavior. In early November, SOHO images showed a faint, sun-facing structure trailing behind 3I Atlas's core, possibly the formation of an anti-tail. As the object swings past and our angle shifts, we may get a rare chance to observe this optical alignment. What does that mean for telescopes? It means photographers should prepare for long exposures. It means stacking techniques may reveal filamentary structures invisible to the naked eye. It means we may witness a two-tailed visitor, where the blue ion tail stretches away from the Sun, while the dust anti-tail appears to lean toward it. A visual contradiction, a cosmic balancing act. And yes, finder charts are already available. As of mid-November, observatories and amateur astronomers have started posting updated sky maps to track 3I Atlas as it moves westward across the celestial sphere. By December 19, it will be visible in the early evening sky, low near the horizon, depending on your latitude. For observers in the northern hemisphere, it may hug the western sky after sunset. For those in the southern hemisphere, late-night views may be clearer. Here is the breakdown. Magnitude to 10, 11. Best dates, December 17, 20. Best time, 45 minutes after sunset, local time. Best tool, 6-inch telescope or better, with long exposure camera for tails. And for those who don't have equipment, many observatories plan to live stream the flyby. Expect coordinated observations from the Virtual Telescope Project, SLU, and university observatories with public outreach missions. These streams will provide real-time tracking, commentary, and if conditions allow visual confirmation of the coma and tails. But perhaps more important than the specs or coordinates is this. We're watching something that doesn't belong here. We're watching a fragment from another solar system, a traveler formed under a different sun, possibly ejected during the birth pangs of a planet we'll never see. Its composition, velocity, and light curve encode data from outside our planetary family. And for a brief moment, we can point a telescope toward that light. That's not just science, that's contact silent, cosmic contact. So whether you're setting up gear in your backyard, tuning into a live stream, or simply walking outside and looking west, remember what's passing above you. Not a comet, not a rock, but a visitor. And it's writing a trail across our sky that we may never see again. It looks like a whisper, a faint streak of light across the black. But what you're seeing, the tail of 3I, Atlas, is not just light. It's the visible result of invisible violence, radiation, ionization, and the solar wind. Let's unfold the mechanics behind it. Every comet or interstellar object that behaves like one develops two distinct tails as it nears the sunday. One is made of dust, the other of ionized gas, and each responds to a different force. The dust tail is shaped by sunlight. Tiny particles, released from the surface, are pushed away by solar radiation pressure. These grains, microns in size, scatter light, creating the soft, diffuse glow we usually associate with comets. But the ion tail is a different story. It forms when sunlight ionizes gases like water vapor, carbon monoxide, or carbon dioxide, kicking electrons off atoms and leaving behind charged particles. These ions are then caught in the stream of solar wind, a continuous flow of high-energy particles emitted by the sunday. The wind grabs them and hurls them outward, forming a straight, often bluish tail that points directly away from the sun, no matter which way the comet moves. This is why 3I, Atlas, may display two tails in opposite directions, one flowing from dust, the other from plasma. But there's a more subtle, deeper signal embedded in all of this. In November 2024, the Meerkat radio array in South Africa detected the OH 18 centimeter line, a key spectral fingerprint of water dissociation. When solar UV radiation breaks apart H2O, one of the resulting fragments is the OH radical. And these molecules, when tumbling in space, emit a very faint radio signal at exactly 18 centimeters. That detection was crucial. It proved, beyond visual observation, that 3I, Atlas, is outgassing water, not just dust or CO2. And it told astronomers that chemical processes familiar from solar system comets were also occurring here. This signal confirmed that sunlight is heating the nucleus enough to sublimate ices and send molecules streaming into space. The fact that we can detect this from hundreds of millions of kilometers away speaks to the sensitivity of modern radio astronomy and to the unusual activity of this visitor. But there's more. The orientation of the ion tail reveals something about the magnetic structure of the solar wind itself. As particles are stripped and swept away, they trace invisible field lines. Small kinks, curves, or discontinuities in the tail may reflect shifts in solar wind speed or polarity. In other words, 3I, Atlas, isn't just emitting data, it's helping us map the heliosphere. Think about that. A rock from another star system, passing through our solar neighborhood, dragging behind it a ribbon of plasma that lets us read the wind. It's not just poetry, it's a measurement. Now consider the structure of the dust tail. Because the object is moving fast and venting asymmetrically, grains of different sizes separate over time. Large particles lag, creating a broad, curved tail, while finer dust forms a narrower beam. If the nucleus rotates, and there's evidence it does, this ejection forms jets, which may appear as fans or spokes in high-resolution imagery. Some models even suggest that a third structure called a trail may appear. Unlike tails, which point away from the sun, trails follow the orbital path. They consist of heavier grains that barely move under radiation pressure. So when you see a comet-like streak, you're not looking at one thing. You're seeing the result of multiple forces. Solar radiation pushes dust, solar wind accelerating plasma, rotation modulating vent direction. Fragmentation disperses matter into arcs. The entire thing becomes a fluid sculpture in space, animated by physics we can model but not always predict. And yet, despite our equations, there's still room for surprise. In early December, amateur telescopes began to pick up hints of a kinked ion tail, suggesting turbulent interactions. Some even reported faint disconnection events, where the tail seemed to snap and reform. These are often tied to coronal mass ejections, CMEs, from the sun, violent bursts of magnetized plasma that slam into comets and slice their tails temporarily. If one hits 3I Atlas around its closest approach, we may witness such a tail disconnection event live. These moments are fleeting, gone in hours, but they reveal the living dynamics between star and visitor. And let's not forget, 3I Atlas is moving fast. At over 100,000 kilometers per hour, it's sweeping through zones where solar wind density, temperature, and flow direction shift rapidly. This creates a kind of interstellar weather map, one drawn in blue and gold across the sky. So, when you see that tail, remember, the light you're seeing left particles minutes ago. The particles were thrown off by heat and stress. The stress was caused by a sun that didn't evolve around, and the path it takes reveals both its story and ours. We chase these tails not just for beauty, but for data, and in that luminous streak, we're watching the physics of another system translated by our own sun onto the canvas of space. What else will it tell us before it's gone? It doesn't belong here, not because it's dangerous or disruptive or alien in any hostile sense, but because its motion doesn't fit. Its path slices through our solar system like a visitor passing through a house not its own. And that's our first clue, the shape of its orbit. Unlike the bound ellipses of planets, asteroids, and typical comets, 3I Atlas follows a hyperbolic trajectory, an open curve, not a loop. That means it isn't coming back. Its velocity exceeds solar escape speed. It isn't just eccentric, it's uncapturable. The numbers confirm it. When you calculate its eccentricity, how far its orbit strays from a perfect circle, 3I Atlas scores higher than any long-period comet catalogued in recent years. The JPL Small Body Database gives a heliocentric eccentricity above 1, even after accounting for gravitational perturbations. That puts it in a rare category. Interstellar objects. We've seen only 2 like this before. First was 1I, Oumuamua, in 2017, a tumbling sliver with no tail, accelerating in strange ways. Then came 2I, Borisov, in 2019, a more normal comet in appearance, but still hyperbolic. Now, with 3I Atlas, we have the third confirmed interstellar visitor. But this one has a tail. This one is active, and it passed close enough to Earth to study in detail. That matters, because interstellar objects are more than just wanderers. They are samples from other solar systems. Imagine that. Imagine if you could hold a grain of dust not from Mars or the Moon, but from a planet-forming disk that spun around an alien star 10 billion years ago. That's what 3I Atlas represents. Its ices, volatiles, and structure encode chemistry not shaped by our sun, but by another sun, one we may never find, drifting now on the other side of the galaxy. That's why its classification isn't trivial. It's a door briefly open into the galactic neighborhood. And here's where things become even more awe-inspiring. The very existence of 3I Atlas suggests something profound about our cosmic environment. The solar system is not a closed room. It's porous. Objects can come in, objects can leave. Every time a star like our sun is born, gravitational jostling sends trillions of icy fragments hurtling outward. Some get trapped in Oort clouds, others fly free into the void. Statistically speaking, the galaxy is filled with such ejecta. The interstellar medium is not empty. It's populated with silent visitors, cold comets wandering without a star, waiting to be pulled into a brief performance by a gravity well like ours. We never see most of them, but occasionally one gets close enough, visible enough, active enough. And when it does, it gives us not just data, but perspective. 3I Atlas reminds us that we are not the only system making planets, that our chemistry is not the only recipe. That material formed billions of light years away can drift into our sky, unseen for eons, and suddenly reveal itself in a streak of light and a curve of motion that doesn't belong. That curve is the signature of an interstellar origin, and its implications, they ripple outward, because if comets can come in, so can amino acids, so can organic chains, so can information carriers. etched in the structure of frozen crystals. The panspermia hypothesis that life's building blocks could travel between stars isn't fantasy anymore. It's a field of study. It's testable. And 3I, Atlas, brings us closer to that test. Its hyperbolic path is more than a celestial oddity. It's a scientific marker, a fingerprint from another neighborhood in the galaxy. And now that we've seen 3 Oumuamua, Borisov, Atlas, it suggests a steady rain of such objects may always be falling, just out of sight, just beyond detection. They aren't flukes, they're messengers, and for 6 fleeting weeks this year, one of them is writing across our sky, in light, ice, and motion, before disappearing forever, back into the interstellar dark. We've seen objects like this before, but not quite like this. Some had tails that curved like question marks across the void. Others blinked once briefly and disappeared into silence. But 3I, Atlas, gives us a window not just into what it is, but what it might still become. And with every kilometer it travels, the questions sharpen. Because this is not just about seeing a comet, it's about listening to what it's made of. The moment it passed perihelion and emerged intact, 3I, Atlas, became something more than a curiosity. It became a laboratory, a moving, glowing, icy lab from another star, hurtling past our sun just long enough for us to ask real questions and maybe get real answers. What are those answers? Exactly. Start with chemistry. Start with breath. Every time a comet approaches the sun, its frozen volatiles begin to sublimate, transforming directly from solid to gas. That's what gives rise to the coma, the faint spherical halo of gas that surrounds the nucleus. With 3I, Atlas, we're not just looking for any gas, we're listening for specific chemical fingerprints. The 0818cm radio line, already detected, is just the beginning. It's a telltale sign of water, specifically hydroxyl OH radicals, formed when solar ultraviolet radiation splits apart H2O molecules. Meerkat caught it once. If we're lucky, we'll catch it again. But beyond water, we're looking for carbon dioxide, CO2, carbon monoxide, CO, methane, CH4, and ammonia, NH3. These molecules matter because they act like timestamps from a different system. Their ratios, their presence, even their absence, tell us how different this object is from the ones born in our own Oort cloud. And if the ratios are strange, that's when it gets interesting. What if this object has CO2, but almost no CO, or high levels of exotic organics, or something we can't explain with the temperature history of our own solar nebula? Each molecule is a clue. Each detection or non-detection is a boundary line in our map of galactic chemistry. But it's not just about what's in the object, it's about what's coming out. Enter the jets. We've seen jets on comets before, plumes of gas and dust that erupt as sunlight heats subsurface pockets. But 3I Atlas may show us jet behavior we've never documented from an interstellar source. And here's where it gets tricky. The way the jets fire tells us about the inside. Jets reveal pressure zones, they reveal fracture geometry, they reveal spin behavior and surface layering. The shape, brightness, and frequency of outgassing events act as a kind of Morse code one we're only beginning to understand. If we can model the surface response to solar heating, we can reconstruct how thick the crust is. If we can map repeated outgassing in the same direction, we can infer rotational locking. If we catch asymmetrical jets, we might even estimate subsurface voids, all from light, all from motion, and all within a window that's closing. You may be wondering, why does it matter? After all, we've seen hundreds of comets. Why chase the molecules of this one? Because of what it's not. This object didn't form near Jupiter. It didn't freeze beyond Neptune. It wasn't nudged by Saturn, flipped by Uranus, or ejected by the Sunday. It comes from somewhere else, somewhere our instruments can't yet reach. And yet, for a brief few weeks, it's here. Every volatile it carries is a frozen breath from another star. Every molecule is a message from a time and place we've never touched. Consider this. If we detect high levels of CO2, that suggests formation in a cold, carbon-rich environment, likely a region far from its home star, or a system with different disk chemistry. On the other hand, low CO2 but strong HCN might imply nitrogen-rich origins, If both are low but hydrocarbons dominate, we may be seeing something formed near a carbon star or from dust left over from a supernova. These aren't just chemical readings. They're fingerprints of another solar system's death or birth. And the way the object responds to sunlight? That gives us hints about how it's aged. Has it developed a crust over millions of years in interstellar cold? Or is it still soft, fragile, porous? We're about to find out. There's another piece. Color. Using multiband photometry, we can infer the composition of surface ices and dust. A redder surface might mean organic tholins, complex molecules formed by radiation. A bluer surface might suggest fresh ice, exposed by recent jets or fragmentation. Color can also tell us if the surface is uniform or patchy, and that, in turn, hints at whether it's undergone collisions or is a pristine fragment. The ultimate goal? Compare, relate, connect. Match what we see with what we know from Oumuamua. Elongated, tumbling, no visible coma. Match what we see with Borisov rich in CO, extremely active, bluer than typical comets. And if 3I, Atlas, is different from both, then we may have just observed a third type of interstellar traveler, one that behaves like neither a rock nor a snowball, but something stranger, a composite, or a survivor of processes we haven't even catalogued yet. Think of it this way. If we had only one sample of life on Earth, we'd never know it could vary. Only by comparison do we find a pattern. Only by pattern do we find meaning. Interstellar objects are the same. One was a rock. One was a snowball. This one is... what? There's a final, humbling thought. All of this, molecules, jets, geometry, light curves, it depends on observation, on timing, on clear skies, and working instruments and teams that don't blink. Because once 3I, Atlas, passes Earth, it's gone. No second orbit, no second look. Whatever we learn now. Or we don't. And that, perhaps, is what makes this more than a scientific opportunity. It makes it a philosophical one. To listen to the universe is to accept the ephemeral. To observe is to accept loss. To point a telescope at a visitor and say, "We see you," before you vanish. It's tempting to treat December 19 as the climax, the moment everything converges, the night the sky will answer. But something easy to miss is this. 3I, Atlas, has already answered many questions. Quietly, repeatedly. While the world waited for a spectacle, science was already listening. And the signals came. Let's start not with a telescope image, but with a frequency, 1,665 megahertz. That's the OH 18 centimeter line, a radio wavelength emitted when hydroxyl radicals are excited by solar UV light, usually after water molecules have been dissociated. When an interstellar object like 3I Atlas emits in this band, it means something simple and profound. Water is present, and it's reacting. That detection didn't come from the sky. It came from deep below it, South Africa. In fact, at the Meerkat Radio Observatory. In early observations, scientists pointed the array at the patch of sky where 3I Atlas passed after perihelion, and there it was, a faint but statistically significant detection of the OH line. No ambiguity, no speculation, just evidence. What does it mean when an interstellar object not only survives the sun but also speaks in the same molecular language as comets born in our solar nursery? It means the line between alien and familiar isn't as clear as we imagined. It means that out there in the darkness between stars, ice still exists, chemistry still flows. And when flung into our sun's reach, that chemistry wakes up and glows. But that's not all we've seen. You might think a comet from another star would behave wildly, tumbling, fragmenting, unpredictable. But so far, 3I, Atlas, has defied that chaos. Its light curve, the measurement of its changing brightness over time, has been remarkably smooth. No chaotic dips, no sudden surges. That suggests a nucleus that's not spinning erratically. It might be rotating, yes, but perhaps slowly, perhaps evenly. And that changes how we model it. Stable light curves suggest surface uniformity, or a well-behaved spin axis. In fact, this steadiness allowed several teams to begin estimating its rotation period, likely between 9 to 15 hours, though this is still under refinement. That may sound ordinary, but for an object arriving from the stars, ordinary is extraordinary. It means we can apply familiar physics. We can map its heating cycles, model jet activation zones, and predict behavior. That's rare. Sometimes, alien visitors don't scream their difference, they whisper their similarity, and that can be even more disarming. Let's talk about brightness. After rounding the sun, 3I, Atlas, emerged into SOHO's field of view. Many expected it to dim, to weaken, to scatter like other overcooked comets. But instead, it brightened, and not subtly, it surged to magnitudes visible, even in small backyard telescopes. No fragmentation trail, no dust field, just a solid, luminous core with structure. Why? That's still debated. Some suggest a buried volatile pocket reached thermal escape velocity only after perihelion. Others propose an active area near a pole finally tilted into sunlight. Either way, the object didn't just endure the sun, it reacted to it, and with timing that implies internal complexity. Here is the surprise. The complexity hasn't unraveled it. We often think of interstellar objects like Oumuamua, fragile, tumbling, light-shifting enigmas. 3I, Atlas, is the opposite. Stable, readable, and at least for now, physically coherent. This coherence may be what's allowing scientists to track its tail morphology so well. From ground-based images, especially from December 1016, a pronounced ion tail began to emerge, straight, sun-antisolar aligned, and consistent with solar-wind interaction. The tail didn't twist, scatter, or break. It held, so we no longer need to ask, will we learn something? We already have, and what we've learned changes how we think about everything we're about to see. Let's rewind slightly. When astronomers first confirmed 3I, Atlas, as interstellar, many assumed it would be another Oumuamua, silent, strange, impossible to follow after it left, but that assumption missed one thing: time. 3I, Atlas, gave us more of it. It arrived slowly, on a long arc, giving telescopes time to aim, time to plan, time to listen, and from that time we gained early gifts. O detection confirmed volatiles. Light curve consistency enabled nucleus modeling. Post-perihelion brightening revealed buried chemistry. Tail stability suggested predictable solar wind coupling. Each of these is more than data. Each is a foothold in the unknown. Before the world even looked up, the sky had already spoken to those patient enough to hear. What a quiet miracle that is. We should talk about shape, but not the objects. Our own. This kind of cosmic event bends our perception of time. We wait for a single night, December 19. But we forget that learning doesn't wait. It happens in background frequencies, in early light curves, in delayed radio signals echoing across a hemisphere. Science doesn't celebrate all at once. It accumulates. That's why part 11 matters, because this is the part where we realize we've already been changed. Not by what we hope 3I, Atlas, will reveal, but by what it already has. And that's a subtle but essential shift. We are no longer observers waiting for a climax. We are participants mid-journey, already holding pieces of the answer. Knowledge rarely arrives in fire. It arrives in flickers, OH lines, fading curves, small consistencies that whisper, you're on the right track. And if 3I, Atlas, vanished tonight, if clouds obscured the rest, if no more signals reached us, we would still walk away with something profound. We would know this. That ice still travels between stars. That chemistry waits, asleep, in cosmic dark. That light can speak before it flares. And that even the smallest signal, caught in time, can rearrange how we imagine the universe behaves when no one's looking. This visitor hasn't just arrived. It's already begun to teach, and we were already listening. They said it might collide. They said the government was hiding something. They said it was a sign, a warning, a threat. But December 19 will not be that kind of day. When we look up, we won't see panic. We'll see geometry perfect and predictable. A path not random, but refined through observation, adjustment, and mathematical beauty. This object, 3I, Atlas, is not on a collision course with Earth. It never was. Astronomers from around the world, including those at NASA's JPL and ESA's NEODISE program, have spent months tracking its every move. Thousands of positional measurements have been input into refined models, And those models all say the same thing. The object will pass Earth at a distance of approximately 0.26 AU. That's about 39 million kilometers more than 100 times the distance to the Moon. Not just a miss, a clean miss. So where did the fear come from? Fear thrives in silence. And 3I Atlas gave us silence for a time when it passed behind the sun, hidden from our view. In that gap, imagination filled the void, and online, in comment sections and viral shorts, fear spread faster than the facts. Some said it was being censored, some said it would appear suddenly, unexpectedly, like a rogue missile from the galactic dark. But the truth is far quieter than that. Astronomy doesn't shout, it whispers, and it takes patience to listen. We've had that patience. Since its reappearance in SOHO's field of view, 3I Atlas has been continuously observed. Telescopes around the world have locked onto it. Spectral data has been collected. Light curves have been plotted. Nothing indicates danger. Everything points to an elegant pass. That's the word that fits best. Pass. Not flyby, not graze, not brush. Pass like a traveller choosing not to knock, only to pass by in silence. Something is comforting in that, because not every cosmic event has to be dramatic to be meaningful. Not every object that visits must leave a scar. Some simply pass through like wind through trees, or silence between notes. And maybe that's the point, to learn that awe and fear are not the same, that we can be amazed without being afraid. Let's revisit the numbers. The velocity of 3I Atlas, as it approaches Earth, will be around 43 kilometers per second. Its trajectory is steep, slicing through the solar system on a hyperbolic path. It isn't spiraling in. It's on its way out. Its time here is brief. At closest approach, it will still be too far to influence Earth's tides, magnetic fields, or atmosphere. There's no gravitational tug-of-war, no Earth-crossing orbital node, and no evidence of any mass large enough to create secondary effects. So what does that leave us with? It leaves us with a gift, the gift of witnessing something pure, motion without motive, path without peril, a reminder that the cosmos is not out to get us, but to be seen, to be understood. This doesn't mean we stop asking questions. It means we ask better ones. Instead of, will it hit us? We can ask, what does it tell us? Instead of fearing the object, we can marvel at the fact that we noticed it at all, because just a few decades ago, we wouldn't have. 3I Atlas would have passed by, invisible to our eyes and instruments. No light curve, no OH line, no December 19 on the calendar. But now, we know. And that knowledge lets us reframe what this moment is. Not a crisis, but a milestone. Not an omen, but a conversation. There's one more thing that needs to be said. Many voices online continue to fan the flames of fear. They speak of alignments, of secret planetary shifts, of apocalyptic visions. But science isn't served by drama. It's served by data. And the data say this: December 19 will come, and December 19 will pass. And when it does, we'll be here, looking back not with relief, but with gratitude. Gratitude that we were paying attention. Gratitude that we live in an age where such things can be seen. So if you find yourself hearing stories of doom, pause. Ask for the numbers. Ask for the data. And when they cannot be given, ask yourself why the story needs your fear to exist. Because this story doesn't. It needs only your attention, your curiosity, your willingness to stand still for a moment and remember that the sky is not just a ceiling, it is a passageway. On December 19, that passageway opens for a visitor. It does not stay, it does not threaten, it does not knock. It only passes. And we, for once, are ready to watch it go. They're all watching. From low Earth orbit to the quiet curve of Martian skies, an invisible web of instruments and intention has been spun across the solar system, not to sound an alarm, not to brace for impact, but to bear witness collectively, precisely, and from as many angles as we can. This isn't the story of one telescope pointed at one star. This is the story of Earth watching together, the story of how a dust grain-sized object from another star has become the center of a planetary choreography. Telescopes on mountaintops, satellites beyond the moon, robotic emissaries trailing ancient asteroids, all aligned for a single event, all are waiting for the 19th of December. It starts with the familiar ones, the workhorses we've relied on for decades. SOHO, silent and stable at L1, positioned perfectly between Earth and the Sun, is still returning images with the kind of quiet consistency that only deep space can offer. Though not designed to study distant comets, it caught 3I, Atlas, at perihelion, flaring into brightness for just a few frames, proving it survived. That alone set off a cascade. If it was still intact, then every eye trained on it was now justified. We weren't chasing a phantom, we were documenting history. Then there's Lucy, still early in its journey toward the Trojan asteroids of Jupiter. Lucy occupies a vantage point no Earth-based observer can replicate. It has the angle, the dark background, the clean view of solar-facing phenomena without the clutter of Earth's magnetosphere. NASA confirmed that Lucy has been allocated observation windows during 3I, Atlas's outbound leg, and even brief glimpses can unlock data about tail orientation, jet activity, and how sunlight interacts with the object's surface. Psyche 2, now en route to its namesake metal-rich asteroid, joins the network. Although Psyche's instruments are optimized for their target, their ability to image faint sources and calibrate background light could contribute to cross-checking positional models of 3I, Atlas. It's less about direct imaging and more about context, using all available signals to constrain the unknown. On Mars, the story takes another layer. The Mars Reconnaissance Orbiter, MRO, known for capturing absurdly high-resolution images of Martian dunes and debris, is being evaluated for a different task: watching the sky. Positioned on the far side of the Sun's glare relative to Earth for parts of December, MRO may offer side-angle data on the tail's orientation, especially if ionization becomes more active post-perihelion. Combined with images from MAVEN, Mars Atmospheric and Solar Wind Observer, we gain not just a photograph but a fluid simulation of how interstellar material interacts with multiple solar system environments. And then there's PUNCH, the polarimeter to unify the corona and heliosphere, designed to image the solar wind itself. Though it's still in preparation, the logic of this mission highlights what December 19 teaches us: that tails aren't just pretty, they're maps of motion, pressure, energy. The tail of 3I, Atlas, isn't merely a streak, it's a thermometer for the galaxy's breath, glowing in lines of ionized gas and long trails of dust, and every instrument pointed at it is another voice in a choir of observation. Ground-based telescopes, too, are part of this net. From the Vera Rubin Observatory's massive survey engine to smaller amateur scopes guided by finder charts downloaded online, the surface of our planet is now dotted with intention. High school students, retired astronomers, professionals calibrating spectrometers on mountaintops in Chile and Hawaii, all with eyes set on the same fragment of sky. And it matters, because distributed observation means more than data. It means triangulation. It means confirming light curve anomalies with multiple time zones. It means that no jet goes unconfirmed, no fragmentation event remains a rumor. If one telescope sees a flash, another verifies it. If one station reports a shift in angle, the network checks. Together, they dissolve coincidence into certainty. The emotional weight of this moment isn't in the number of lenses aimed skyward. It's in what that effort represents. In a world so often fragmented by noise, this is a signal. One clear, global signal that something rare is passing us and we're ready. Not afraid, not divided, ready. Even telescopes not designed for cometary science have been redirected, reprogrammed, or rescheduled to catch it. Instruments like the Infrared Telescope Facility, IRTF, the Canada-France-Hawaii Telescope, CFHT, and the Hubble Space Telescope are being considered for target of opportunity campaigns. Because time is short, and the universe doesn't reschedule. And then there's the Deep Space Network. Not to imagine, but to communicate. Not with 3I, Atlas, but with the machines watching it. Every image taken by Lucy or SOHO or MRO is only as useful as the precision with which it's transmitted and time-stamped. The DSN ensures that the choreography of observations is preserved not just as a moment, but as a map. This is what the scientific method looks like on a planetary scale. A shared focus, a silent agreement that some things are too rare to ignore, too beautiful to miss, and too important to leave to chance. We won't get this geometry again. Not with this object. Not with this proximity. Not with this symmetry of tail and sun and earth. So we aim for everything we have. We pool silence and patience and photons. We log timestamps and compare shadows. We wait. We don't do this because we expect something catastrophic. We do it because, for once, the entire planet looked up and agreed it was worth watching. And maybe that's the most remarkable thing of all. Maybe you don't have a telescope. Maybe you live in a city with too much light. Maybe the sky where you are never feels quite dark enough. Still, you can be part of this, because this isn't just about what you see. It's about what you know is happening above you, around you, across this planet. On the night of the 19th of December 2025, something rare, something interstellar, will pass through Earth's view. And whether you're in the high deserts of Chile, the frozen quiet of Svalbard, or sitting by a window in Sao Paulo, the sky will hold a trace of it. And maybe, just maybe, that's enough to feel it. Let's begin with the obvious question. Can you see 3I, Atlas, with your own eyes? The answer is, it depends. Its projected magnitude will likely hover between +7 and +9 around closest approach. That means it won't be visible to the naked eye, not even in the darkest skies. You'll need binoculars, or better, a telescope. But it's not just about owning the gear, it's about knowing when and where to point it. The Virtual Telescope project, led by astronomer Gianluca Marzi, has already confirmed multiple live streams for this event. These are not simulations, they're real-time feeds from professional-grade instruments, capturing the comet as it streaks through the darkness. No matter where you are in the world, if you have internet, you'll be able to see 3I, Atlas, from multiple angles, some even with commentary, guiding your eyes, explaining the jets, the brightness, the motion. But perhaps more important than what we can show you is what we can help you feel. Because live streams aren't just digital windows, they're emotional bridges. They connect isolated observers, they synchronize human eyes across continents, they let a child in Manila gasp at the same tale as a student in Morocco. And for that one brief moment, no one is alone with their curiosity. If you do want to try seeing it directly, the finder charts will matter. By mid-December, 3I, Atlas, will move rapidly through the constellation Pegasus, cutting a visible arc night by night. Astronomy websites like Heavens Above, Sky Safari, and Stellarium are already preparing sky charts calibrated for various time zones. These maps will show you where to look and when. If you have a modest telescope, say 4 or 6 inches of aperture, you'll likely be able to see a faint, fuzzy smudge. It might not have the long, dramatic tail we imagine from movies, but its presence will be unmistakable, a grain of light that doesn't belong, moving with purpose against the backdrop of fixed stars. To catch it best, you'll want a dark sky. Light pollution is the enemy of wonder, so if you can, travel. Get outside the city. Find a hillside, a beach, a mountain trail. Let the earth turn underneath you as the sky does what it's always done: reveal, conceal, and wait. Even if you see nothing at all, you'll know. You'll know that above you, a visitor is passing, a traveler from another system, from another sun, from another time. And you were here for it. Here is something quiet but beautiful. This moment is one you can choose to be present for. You don't need to document it. You don't need to post it. You don't need to prove you saw it. Just knowing it's happening, pausing to mark that, is enough. This isn't the kind of story where everyone needs to become an expert. It's the kind of story where everyone gets to feel invited. If you've never followed a comet before, this is your perfect first. Not because it's the brightest, not because it's the most dramatic, but because it's the most unlikely. Think about what this really is: a fragment of another solar system. Something ejected from the gravity of a foreign star perhaps billions of years ago is now threading its way past Earth. That path was never guaranteed, but it's real, and you're alive for it. Astronomy clubs across the world are organizing shared viewing nights. Universities will be live streaming through campus telescopes. Amateur observers on YouTube will post real-time tracking videos, some even stacking images live to help show the tail structure. If you don't want the noise of commentary, you can simply load up a dark stream, just a silent field of stars, and watch as a dim point of light moves pixel by pixel. It won't scream for your attention. It won't glow like fiction. It will simply drift, and that will be enough, because there's a magic in seeing something that doesn't know you're watching. No performance, no need for approval, just trajectory, and silence, and time. There's one more way to witness this event, through intention. Pick a time on December 19. Mark it in your calendar. Set an alarm, if you like. When the moment comes, go outside, look up. You won't see 3i Atlas with your eyes, not unless you have tools. But you'll know that it's there, and maybe, just maybe, it will know you're there too. After all, the sky remembers everyone who has ever looked up at it. You could be one of them, because in the end, this is not a spectacle to be consumed. It's a moment to be lived. No matter how quiet your life feels right now, the universe has decided to send you something. A visitor, a mystery, a reminder. And all it asks is that you notice. It won't explode. It won't turn. It won't come back. It will just leave. That's the part no simulation shows. The moment after the closest approach, when all the cameras shut off, when the telescopes return to Jupiter's storms or Saturn's rings, when the headlines fade, when nothing is left to chase except distance, 3i Atlas will keep moving, of course. That's what it's always done, since before we had calendars, before we had names. It entered from the dark, silent and unseen, and it will exit the same way, slipping quietly into the deep sky, behind the geometry of numbers. You won't feel it go, but you might feel something change, because even after all the talk, all the tension, all the speculation, nothing will have happened. Not on the surface, no shockwave, no flash, no collision, just an object, still moving. But well no, those who watched, those who stayed up late or rose before dawn, those who aligned their lenses and waited through the noise, they'll remember the shape of the tail, the tilt of the anti-tail against the stars, the strange steadiness of the core, the frame number where it last flared, and the chart where it began to dim. That's what passing means in astronomy. Not vanishing, but fading. A slow surrender to distance, a return to silence not because it's gone, but because it's beyond our reach. By January, 3i Atlas will begin its outbound leg, climbing up and out, escaping the inner solar system. Its trajectory will remain hyperbolic, not bound, not circular, not elliptical. No sun can hold it. It came from elsewhere, and it's returning to elsewhere. That trajectory will curve upward across the ecliptic, reaching toward the northern constellations, but its brightness will fall off sharply from magnitude 6, 5 to 9, then 12, then gone. Not because it stopped glowing, but because light loses battles to space. And yet, there's something poetic in that exit, because even as it fades, it's writing data into the void. Its motion will be logged by ESA's Gaia. Its tail shape will be recorded by amateur astronomers from Brazil to Vietnam. Its dust distribution will be archived in the virtual telescope stream. Its OH emissions will ripple through Meerkat sensors one last time. And someone, somewhere, will download a CSV file. They'll scroll down. Line 412. Observation date, December 23. Signal detected. Object, 3i Atlas. That's all that will be left. A line in a dataset, a tail on a plot, a brightness drop on a curve, a ripple of memory in the bodies of those who watched. And maybe that's the point. In a universe this large, not everything that matters explodes. Some things just pass close enough to wake you, close enough to be real, and then they go. 3i Atlas is that kind of encounter. It doesn't ask for fear. It doesn't demand prophecy. It doesn't grant answers. But it does show up. It does align. It does hold its vector with impossible dignity. Most comets don't get a goodbye. They disintegrate, fragment, stall, get pulled into orbits that drain them dry over millennia. But not this one. This one survives its sun kiss. It keeps its axis. It holds its jets. It answers the questions we asked and raises more we didn't think to phrase. And when it passes, it won't just leave space behind. It will leave silence. The kind of silence that's not empty, but full of attempts, of observations made, of diagrams drawn, of YouTube comment debates, of corrected tweets, of family members shown a faint smudge on a screen and told, "That's it, right there," and someone saying back, "That? Yes, that's all we ever get. A small thing, glowing for a while, going away. But we're different now, not because it changed us, but because we noticed. And in noticing, we remembered something we always forget, that space isn't still, that the universe is in motion, that visitors don't wait for us to be ready. They come when they come, and they leave when they must. The outbound path of 3I, Atlas, will be tracked for as long as we can see it, but at some point, maybe March or April, it will drop below all known thresholds. No more tail to analyze, no more light to split, just coordinates. And then it becomes what it was before we knew its name, a distant object moving away. But that phrase means more now, because for a brief window, it moved toward us. For a time, it was close enough to measure, to name, to contemplate. And in the brief geometry of that encounter, something was exchanged. Not gravity, not energy, but awareness. Of the sky, of ourselves, of the quiet truths that only moving light can reveal. So when December 19 ends, don't wait for fireworks. Don't expect a twist. Just step outside, look up, and know that somewhere out there, a traveller is continuing. And we, on this little rock, under this temporary sky, got to see it. That was the gift. And now, it's time to let it go. There's a silence that follows an object like this. Not the silence of indifference, but the kind born from knowing this is it our only moment. One pass, one curve, then gone. 3I. Atlas isn't coming back. It's not following a looping ellipse like the comets we've charted for centuries. Its trajectory is hyperbolic, wider than a circle, flatter than a parabola, and carved open at the ends. That shape alone tells us everything. This isn't an object bound to our Sunday. It's just visiting, and it won't stay. Let's slow down and really absorb that. A hyperbolic orbit means it was never captured. Our star, immense, ancient, gravitationally dominant, wasn't enough to hold it. 3I, Atlas, entered the solar system with a speed greater than the sun's escape velocity. That's like threading a needle in reverse, from the outside in, and still having enough speed to leave the room once the pass is complete. Its inbound velocity, calculated from early observations, exceeded 26 kilometers per second relative to the Sunday. And even after solar interaction, after perihelion, outgassing, and tail formation, it retained escape velocity. There is no looping back, no second pass, no long elliptical return. That's what makes December 19 such a sharp moment in time. It's not just a close approach, it's the approach. After that, every kilometer, it travels, moves it farther and farther from Earth, from the Sun, from the inner solar system forever. This kind of trajectory is more than a shape on a chart. It's a story told by gravity itself. Our Sun tried. It reached out with its massive pull. But 3I, Atlas, was moving too fast, too free, too interstellar. It dipped into our system like a cosmic skipping stone, touching light, shedding ions, glimmering dust, and then lifting away. Astronomers don't say this lightly. One-time event isn't marketing. It's orbital mechanics. We can project the trajectory forward. After it passes Earth, it continues outward into the void. The numbers tell us it will head toward the outer Oort cloud region, briefly intersecting deep solar space, and then drift into the galactic tides again. There are no hidden planetary slingshots ahead, no gravitational tricks that will pull it back, no path correction that will change the inevitable. Even Jupiter, the great deflector of our system, won't be in a position to alter its escape arc. Its fate is sealed in math. Why does that matter? Because in astronomy, we often get second chances. Halley's Comet returns every 76 years. 67P, famous from the Rosetta mission, swings back every 6.5 years. Even long-period comets like C 1995 01 Hale-Bopp give us arcs that, while vast, promise eventual return. But not this one. 3I, Atlas, joins a short list of cosmic visitors that give us only a single glance. Oumuamua, Borisov. And now this, a kind of astronomical one-night stand, rich in mystery, impossible to follow up. That uniqueness transforms how we treat the data. There's urgency in every observation, every telescope pointed, every spectrogram analyzed, every image stacked becomes more than just science, it becomes memory formation. Collective memory, the kind that astronomers carry through decades, often quoting the date like a birthday or an eclipse. You'll hear them say it with reverence. We had one chance. We took it. So December 19 is not just a checkpoint, it's a farewell, a salute to an object that will soon cross the event horizon of our observation, not into a black hole, but into the cold anonymity of deep space, where even our best instruments will lose track of its fading trail. This is the paradox of cosmic time. The universe is eternal, but our windows into it are brief. A galaxy turns like a clock, but the second hand sometimes ticks just once. We're lucky then. Lucky to be alive during this moment. Lucky that the instruments exist. Lucky that someone, likely a lone astronomer, at the right time, first saw the faint dot, now commanding global attention. And luckier still that, for one day, that object will be closer to us than ever again. We should meet it with attention, look up, or log in, or just pause. Whatever presence looks like for you, bring it to December 19, because the trajectory of 3I, Atlas, is more than a curve. It's a line that connects us to the galaxy and then moves on, without waiting, without asking. And that is the most humbling thing. The universe does not linger. Its messages arrive without a return address. They pass, and we decide whether to notice. This is one of those moments, and we only get one shot. It's easy to forget how much of our daily life is confined to the narrowest of scales. We check our phones, we watch traffic lights change, we worry about minutes and megabytes and missed deadlines. And yet, above us, something vast and slow and impossibly old just passed by quietly, unannounced, uninvited. 3I. Atlas is not just a rock moving through space. It's a letter from another star system, a particle of a story that began somewhere we can't see, in a time we can't name, written in a language we're only just learning how to read. And somehow, it came here near enough to touch with telescopes and names and metaphors and human hope. Most of the universe doesn't visit us. The stars stay where they are. The planets in our own solar system circle predictably, like dancers in a choreographed routine. But every once in a while, something foreign crosses the floor. Something that doesn't belong to this family of 9 planets and their moons. Something whose very orbit breaks the rules our textbooks rely on. Something interstellar. And in that moment, we are reminded of something important. We are not alone in the galaxy. Not in a social sense, perhaps, but in a structural one. Our solar system is not a closed loop. It is a porous membrane, occasionally letting visitors through. Some people might wonder, why does this matter? Why care about a frozen object hurtling through space that will never come back? Because in observing it, we are reminded of where we are. Because in tracing its path, we glimpse the shape of the larger map. Because in seeing it just once, we realize how much we haven't seen. Perspective is a gift science gives us not as data points, but as reorientations of the soul. We are not the center of the universe, not even close, but we are observers with hearts. We are the ones who care enough to look up, to ask, to wonder. And that, too, is part of the story. Consider this. The photons bouncing off 3I, Atlas, just days before its closest approach will enter our atmosphere, bounce through layers of air, pass through lenses of glass or silicon sensors, and eventually, one by one, they will end their journey in a human eye. That single act, multiplied by millions, is the core of astronomy. Light from far away, entering the soul of a witness. And that witnessing is what transforms a rock into a story. We don't see it with the same detachment we'd use for a piece of debris. We see it the way pilgrims see a holy site, the way an archaeologist sees the first inscription of a lost language. It's not just material, it's meaning. The interstellar nature of 3I, Atlas, reminds us that stars eject things. Planets may form, or may not. Objects are thrown out, sometimes by gravitational billiards, sometimes by explosive drama, and what's ejected becomes, for billions of years, a silent traveller. No star to orbit, no heat to warm it, just the long drift across galactic space. And then miraculously it crosses paths with another star system. With us, think of the odds. A single object, ejected from some unknown parent system, enters our Oort cloud, falls in under the influence of our sun, passes close enough to be seen, and then, just like that, fades away forever. We don't get to know where it came from. We don't get to ask it questions, but we do get to watch, to learn, to listen. And that is enough. Because the act of watching reshapes us. It reminds us how temporary our view really is. Most humans live their whole lives without seeing anything interstellar. Most civilizations, even with telescopes, never catch one in action. And yet we, by sheer timing, are here now. Awake during the moment, tuned to the right frequencies, looking in the right direction, it feels like a gift. The ancients used to call comets omens, harbingers of change, signs from the gods. They didn't understand the physics, but they understood the psychology, because something in us is always stirred by a light that shouldn't be there, a movement across the stars that breaks the pattern, something not repeated, not cyclical, not permanent. 3I. Atlas is not a threat, but it is a challenge to pay attention, a challenge to use this moment well, a challenge to listen to the universe when it whispers. For the most part, the cosmos is quiet. It doesn't announce its revelations. It doesn't shout. It reveals itself in fragments in tales that glow for just a week, in chemical lines that fade in radio silence, in small shadows on sensor arrays, and it leaves us to do the rest. To interpret, to ask the right questions, to sit in the unknowing without closing the door. Maybe that's the real gift of 3I. Atlas, not certainty, but humility. Because we didn't summon it. We didn't prepare it. It just happened to cross our path. And instead of control, all we have is reverence. There's something beautiful about that, about living in a universe where not everything is predictable, where mystery still exists. The map is still incomplete. The philosopher Carl Sagan once said, "We are a way for the cosmos to know itself." And when 3I, Atlas, passed by, it was as if the cosmos looked in a mirror, and so did we. Its hyperbolic arc is a reminder of all the stories we'll never know in full, all the star systems that rose and died before we were even oxygen-breathing creatures on a wet blue rock, all the frozen messengers that didn't make it this far, and all the others, still drifting in darkness, waiting to be found. There is something profoundly human about trying to understand something that will never speak back. That's what we do. We love the silent, the unreachable, the mysterious. We name it. We chart it. We trace its trajectory across our sky and across our minds. We make meaning from motion. We draw stories from silence. And in doing so, we participate in something larger than ourselves, not just science, but a kind of communion, a shared gaze across time and space, a moment of unity with everyone, whoever looked up and felt small in a good way. Maybe that's the closest thing to truth we ever get. Not answers, but awe. That we're here. That we get to witness. That something from another star just brushed past our corner of the galaxy and gave us, for a fleeting moment, a reason to remember how lucky we are to be alive and aware. And that, perhaps, is the real meaning of close encounters. Not proximity, but presence. There's a strange comfort in realizing that this isn't our first interstellar visitor. Before 3I, Atlas, 2 others crossed the cosmic border and gave us something to think about. They arrived without permission, without explanation, and without warning. And each of them, in their own silent way, rewrote the boundaries of what we thought we knew. In October 2017, a telescope in Hawaii caught sight of a fast-moving object. Its shape was weird, elongated, maybe pancake flat, maybe cigar-like. Its trajectory didn't loop back like an ordinary comet or asteroid. It came in, turned, and left. Hyperbolic, unbound. It was the first confirmed interstellar object ever observed by humanity. They called it 1I, Oumuamua. And though it left quickly, it didn't leave quietly. Oumuamua defied explanation. It had no visible coma, no sign of dust or gas escaping, yet it exhibited non-gravitational acceleration. That is, it sped up slightly as it left the Sunday, no tail, no jets, no clear outgassing. Just a tiny push that shouldn't have been there. Some scientists speculated it was a thin sheet of ice. Others proposed exotic hydrogen ices. Avi Loeb, the Harvard astrophysicist, even put forward the now infamous suggestion. Perhaps it was an artificial light sail, a relic of a civilization we'll never meet. It didn't matter what theory you believed. The real impact of Oumuamua was that it cracked open the door. It showed that our solar system is not isolated, that things from other stars can and do pass through our neighborhood. Then came Borisov, 2I. Borisov was a very different kind of visitor. Discovered in 2019, it looked much more like what we'd expect from a comet: bright coma, a clear tail, and outgassing behavior. It even had a similar composition: cyanide, water, carbon monoxide. It felt familiar, but its speed and orbital shape told us otherwise. Like Oumuamua, Borisov was on a hyperbolic path. It came from deep space, likely ejected from its own star system billions of years ago. But it was more comet-like in every way. Where Oumuamua was strange and dry, Borisov was wet and active. And now, 3I Atlas. What makes 3I Atlas so interesting is that it seems to blend the mysteries of both. Like Borisov, it shows signs of cometary activity. There is an ion tail, detected jets, and a probable coma structure. But like Oumuamua, it has behaviors that don't fully align with standard expectations. Its light curve shows strange stability, its tail seems to shift orientation more than we'd predict, and it's already produced data, like the OH18CM line from Meerkat, that hint at internal chemistry we're only beginning to decode. Each of these visitors tells us something unique. Oumuamua taught us humility. It came and went before we could ask the right questions. Its mystery remains unsolved. Borisov taught us familiarity. It showed that even comets from other stars can resemble those from our own. The building blocks of planetary systems might be more universal than we thought. 3I Atlas teaches us timing. We knew it was coming. We had months to prepare telescopes, run simulations, and coordinate networks. And still, it's surprising us. This sequence, Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2024, 2025, marks a new era of cosmic attention. Once upon a time, interstellar objects were theoretical. Now they are data points. And it changes everything. It means our solar system is porous. The void between stars is not empty, but filled with wandering fragments of other worlds. That our story is not self-contained. Even the chemistry matters. Borisov showed excess CO levels, far more carbon monoxide than typical solar system comets. This might mean it formed in a colder region, farther from its star, or that its parent star was very different from ours. 3I Atlas, with its OH line and possible water content, gives us another layer. If we can detect CO2 or map out isotopic ratios, we might begin to triangulate where it came from, what kind of stellar nursery forged it. And if we're lucky, the light it reflects and the jets it emits may carry fingerprints from another star's protoplanetary disk. Imagine reading the birth certificate of a world we'll never visit, written in molecules and motion. That's the power of these visitors. They don't stay, they don't speak. But if we listen carefully, if we measure with precision and patience, they tell us how stars form, how systems break, and how the galaxy shares its debris. There's also the emotional arc. With Oumuamua, we felt the thrill of first contact with something alien, not in the sci-fi sense, but in the purely astronomical one. With Borisov, we found something oddly comforting, a sense that we weren't so special after all, that other systems create comets too. With 3I Atlas, we feel something different. Preparedness. We saw it coming. We watched it vanish behind the sun and reappear. We tracked it. We measured its jets. We anticipated its closest approach. And perhaps, this time, actually finish the sentence. Have a beginning, middle, and end. Light curves, spectra, imaging, radio signatures, a full arc of observation. If we succeed, 3I Atlas will be more than a headline. It will be a case study, a foundation, a lens through which we understand every future object that enters from the cold. And there will be others. The more we look, the more we find. Our telescopes are sharper, our surveys deeper, our software smarter. Interstellar objects are not rare, they're just hard to catch. But now we know what to look for. The lesson from 3I Atlas is this: the cosmos does not whisper to those who wait. It speaks to those who listen, and when we finally listen, we hear stories older than Earth, written in ice and rock, told in silence and distance. These are not just visitors, they are reminders of what drifts between stars, of what we still don't understand, of what it means to live in a galaxy where everything moves and nothing stays forever. We don't usually get to know, ahead of time, that a moment is historic. Most events that shape memory, personal or planetary, don't come with a countdown. No timer ticking down to significance. No map that says, "Here, look up, this is when it happens." But this one does. There is a line on the calendar. There is a place in the sky. There is a finite window when millions of us will share the same visitor, under the same darkness, across oceans and languages and hemispheres. Not metaphorically, literally. December 19 is not a theory. It is an appointment. And this is our moment, because there will not be another one. Not with this object. Not in this way. Not in this sliver of the cosmos, at this point in our species' unfolding awareness. In a universe that loves to hide itself in distance, silence, and ambiguity, this is rare, a known unknown, a mystery we can point at, a question we can see with our own eyes. And that changes everything. For once, we're not looking backward, trying to reconstruct something ancient from scattered signals. We're not digging through layers of planetary geology or spectral fossils from stars that died before Earth was born. We're here, now, present at the event. This is not about discovering something after the fact. This is about being part of it while it happens. We will watch its trajectory play out in real time. We will track the angle of its tail. We will map the shift in its brightness night by night. We will compare notes across telescopes, backyard mounts, and observatories alike. We will listen for radio echoes, record their spectra, and archive their glow. But more than that, we will remember. And memory is not just personal, it's collective. Civilizations are built not just on stone or steel or code, but on shared memory, on stories we tell about the things we saw together, the things that crossed our skies and left an imprint. Think of Hale-Bopp. Think of Shoemaker Levy 9. Think of Oumuamua. Now think of this, an interstellar traveler with a jetting core and a glowing anti-tail, cutting through our system on a trajectory that never repeats. We are the only generation in all of human history that will witness it, the only one. There's something sacred about that. There's something sacred about witnessing it all. Because to witness is not just to observe. It's to carry, to hold what was seen and pass it on, to keep it alive in words, in images, in awe. We are the light cone of this moment. A light cone is what physicists call the set of all things that can be affected by a single event. You are inside the light cone of 3i, Atlas. So is everyone alive right now. So is every telescope aligned to the sky. Every student is tuning in. Every child who will remember the night someone pointed and said, "Look there." We will not all see the same thing. Some will see a speck of motion on a digital screen. Some will see a faint wisp near the horizon. Some will see only diagrams and data streams. But that's not what matters. What matters is the act of presence. To slow down long enough to say, "I was alive when this happened. I looked up. I made time. I remembered my place in the story." It doesn't have to be spectacular. It just has to be real. And it is. The orbital models aren't uncertain. The data is clean. The predictions are solid. It's coming. It will pass. It will leave. What we do with that is up to us. We can scroll past. Let the algorithms carry it away. Or we can pause. Not because it's dangerous, but because it's beautiful. Not because it threatens us, but because it reminds us how rare it is to be here now, with the clarity of knowing that something unrepeatable is unfolding in the same sky we've always had. This isn't just about astronomy. This is about memory. Shared sky makes shared story. Shared story makes shared meaning. And shared meaning makes us human. Even if we never figure out everything about 3i, Atlas, even if its core remains mysterious, even if the jets confuse us, even if the OH line flickers and fades, the story will remain. We witnessed. That's all history ever asks. Not certainty, not a conclusion, just presence. And this time, we have it. We're not reading about it in a textbook. We're not waiting for someone else to tell us what happened. We're part of the moment. We're part of the data. We're part of the light. Maybe that's the real gift. Not the object, but the window, the opening, the awareness that right now, somewhere beyond the moon but closer than most stars, something from another system is saying hello in the only language the cosmos speaks: motion, light, silence, return. And we get to answer. By watching, by remembering, by honoring the rare clarity of a date written in both mathematics and meaning. December 19 is not about fear. It is not about drama. It is about choosing, for once, to be awake to the story unfolding around us. This is our moment. Not because it changes the universe, but because it changes us. It was quiet before the comet came. Just sky. Just silence. Just the same stars we've always known. But now, something new has crossed that sky. And that changes us. 3I, Atlas, will not crash into Earth. It will not announce itself with a bang or a flare. There will be no dramatic exit, no fireworks, no final scream of light. It will simply move past us, beyond us, on a trajectory that bends away forever. But for a moment, it was here, and we saw it. We watched, and that act matters. We watched not because we feared. We watched because this kind of watching shapes us. In a world that moves too fast, that forgets too quickly, that fills every silence with noise, we paused, and we looked. We looked at something that didn't ask to be seen, something that didn't care whether we were watching. And in that quiet distance, we remembered what it means to witness without needing to control. This is the gift of the cosmos. It doesn't perform. It doesn't play to the crowd. It simply is. And when we watch it with care, we begin to feel something subtle inside us shifting. December 19 wasn't just a day. It was a mirror held up to time, to wonder, to the question of who we are when we are not distracted. 3I, Atlas, was never about answers. It didn't deliver new laws of physics. It didn't rewrite gravity. It didn't reveal alien tech or cosmic messages. What it offered was presence, the kind of presence that exists only once. No second pass, no orbit to complete, just a line drawn once through our sky and never again. We measure orbits and tail structures and OH emission lines because that's what science does. But beneath the data is a story older than science, the story of what it means to watch something arrive from nowhere, pass through everything, and return to the silence. It's the story of memory, because long after the telescope data is archived, long after the headlines fade and the charts are outdated, some part of us will still remember. Not the numbers, not the velocity or magnitude, but the feeling, the breath we held, the cold air on our skin the night we stepped outside to look up, the hush between words, the strange light that moved in a way nothing else ever had. That's what we take with us. Astronomers will debate the coma size, the fragmentation models, and the tail angle geometry. They'll write papers and run simulations and argue over classifications. That's part of the legacy, but it's not the whole of it. Because some things don't need consensus. They need witnessing. We were here. We saw it. It's easy to forget that we're not the center of things. Easy to believe the sky is empty unless it speaks directly to us. But interstellar objects remind us of a deeper truth. The universe is full of stories that don't revolve around us. And when one of those stories briefly intersects with ours, the only correct response is reverence. Reverence isn't about belief. It's about attention. We paid attention. Some people missed it. They'll scroll past headlines or say they don't see the point. That's okay. The sky does not require everyone to look, but for those of us who did, the moment is real, and it doesn't need to be dramatic to be profound. Think of the Voyager probe still drifting beyond the edge of the solar system. Think of pale blue dots. Think of photons traveling millions of years to reach your eye for one brief second. These are not loud events, but they echo forever. So does this. 3I, Atlas, passed us by, but it left something behind. Not a trail of debris, not a gravity wave, something softer, a question, a pause, a moment in which we remembered what it means to be small, and therefore to belong. Because scale doesn't diminish meaning, it refines it. The larger the cosmos, the more rare it becomes to witness something unique. And this was unique. We watched an object that no human had ever seen before, and none will see again. Not like this, not in this geometry, not from this earth, under this sky, with this breath in our lungs. And if that doesn't stir you, wait. Wait until the next time you look up, and the sky feels just a little different. It's not because the sky has changed, it's because you have. That's what watching does. It doesn't give you power, it gives you perspective. Perspective isn't loud, it doesn't trend, it doesn't demand attention, but it lasts, and it grows. We don't know what else is out there. We barely understand what just passed us. But we know this. We paid attention. We didn't miss it. We stood still long enough to say we saw you. And maybe that's enough. The cosmos doesn't promise revelations. It offers moments. This was one, and we accepted it. With cameras, with telescopes, with data, but also with silence, with breath, with wonder, with that quiet recognition that not all things come with an answer, and not all answers need to be spoken aloud. We watched, and that changes us.